All right, so let's start implementing our RacquetBall Pro simulation with object-oriented design. So first, let's revisit our main class, main method, which will make a call to print intro, get inputs. It will create an object of SimStats, and then we'll play the game. We'll print the results. And notice here that two of our helper functions, print intro and get inputs. We did have them in the past, so I'm just going to copy and paste, and then this is our print intro. Quite simple introduction. And get inputs will input A, B, N, and it will return them. So this is enough to test. And by the way, the line after main call, this is what we call the main. In line 34, this is just here to make sure that when we run the program on terminal, it doesn't quit right after it's done. It will wait for us to hit enter. So this is enough to test. So I'm going to, I can only test print intro and get inputs. I cannot test the main yet. So I'm going to disable comment out the main for now. And maybe this one too, just in case. Right, so this is enough to test print intro and get inputs. So here I am in a folder called like 12. Here I've got RacquetBall .py. So I'm going to call this so we can test. So I can call print intro, and it will print the introduction for us. Okay, and next is I can call the get inputs function, which will ask for prob A, we can say 0.5, ask for prob player B, we can say 0.6, and how many times to simulate? We want to simulate 5 games. There you go. All right, so next video we're going to start implementing the SimStats. So the very first class that we're going to start implementing is the player. A player keeps track of service, probability, and score. So first thing we need is we need a constructor that will take a prob for a player and which will create a player with this probability. So what we should do is we should create a self prob, which is prob. We'll receive this from the constructor. We also need to create a another instance variable for score. Okay. That is set to 0 for initially. Okay, and then we need to define another behavior. Let's call this wins serve. Okay, this will take self, and the definition of this is this function returns a boolean that is true with probability self prob. So for this we need to create a probability whether we will win a serve or not. So first thing we need to do is we need to import, you can say from random import random. Okay, then down here we can say return random. So random function will generate a random number, random value between 0 and 1. If that is less than or equal to self dot prob, okay, will return true, otherwise will return false. So, and our next function is def increase score. This will also take self, and then okay, so this function will add a point to this player's score. So we can say self.score plus equal to 1. Keep it simple. Okay. And our next function, def, we can get score, which will return score. Okay. And then returns this player's current score. All we can do is return self dot score. All right, so we're done implementing the player class. So let's go ahead and test this. I'm going to interactively call this function file. Then we have a class called player. So what can we do? We can say player1 is a player. As far as the constructor go, we need a probability. So let's pass a probability for 0.5, which is 50% win rate. And then we can say player1 dot wins serve will get true or false. So we win one service and another one and another one and we lost one. So this is how each time we call win serve, based on the probability rate, if this is high, we have higher chance to win. Okay, so then we can increase score. We can say player one dot inc score. Let's call this 3 times, and then we can say player one dot get score, which will say our score for player one is 3. And yeah, this is how we implement the player object. All right, so let's start implementing the RBall game. A RBall game represents a game in progress. A game has 2 players and then keeps track of which one is currently serving. So our initializer will take prob A and prob B, and it will create a new game having players with the giving probs. So what we're going to do is we're going to create a player A, which will be a player with prob A. And then likewise, we're going to have, let's make sure we call the self. So another self player B, which will be player with prob B. Okay, and then lastly, our constructor will create another instance variable called server. So with server, which will keep track of which of these 2 players is the current server. So to start, we're going to make sure player A is the server. So we could actually randomly choose who will start, but that won't be super important for us. So we're going to decide, we've decided that player A is always the server. Okay, so and the next we need to construct a define a play method which will play the game to completion, and then the play method will also use is over, which a method returns the game is finished. So if player A has won or player B has won, it will also have a change server method which switch which player is serving, and it will also have a get score which returns the current score of player A and player B. So let's implement is over, change server, and get score. Finally, we'll implement the play score. So in is over, we're going to say we're going to get the scores for okay, let's go ahead and implement get score first. So returns the current score of player A and player B. So notice that player A and player B are players, so we're going to use this get score method for each. So we're going to say return self dot player A dot get score, and then separated by comma we can also return self dot player B dot get score. So this get score in the RacquetBall game will return scores for both player A and player B. Then we can decide which of them we can decide whether the game is over or not. Okay, so we can say for A and B self dot get score. Again, remember it will return the score for player A and player B, and then it will compare the scores to make sure that we have a winner. So how do we know? We can say if A, this is score A, is 15 or B is equal to 15. Okay, this is one case though. So if one of them has reached 15, the game is over. We can also say that, or can also say if A is 7 and B is 0, that's shootout. We can also say B is 7 and A is 0. Okay, this is also another case where one of them wins. So the next is the change server. So we're based on how the players either win or not. So the server has to change. So how do we do that? We can say if self.server. So remember server serves, and then if self.server is equal to self.server A. If that's the case, and then we can say self.server is self.player A. Okay. If self.server is self.server A, self.server is player B. Sorry, confusion. Okay, and else self.server is self.server A. Okay, so if the current server is A, we switch to B. If it's B, we switch to A. Okay, so we have successfully implement get score is over and change server, and now it's time to play the game. So how do we play the game is we can say, remember this is a continuous play. It will play until one of them wins the game. So each time we play a game, one of them has to win. How? We can say if not, self dot is over. Okay, remember is over tells us whether the game is over or not. Yeah. So if while not self dot is over, which means the game's gotta continue, then we can say if self dot server dot wins serve. So we basically use the probability whether whoever is serving, if we see based on the probability, if they win, then we can increase the score for the server. And server dot inc score. Okay. Else we need to switch the server. So then we can say self dot server let's call it change server. Yeah. Okay. So well, repeat this again. While not is over, while game is playing, if server dot win serve is true, which means we serve and we win, so we can increase the score. And else, which means we served and we lost, then we change the server, and the next server will actually try to win or not. Okay, so that's how we implement the RacquetBall game. Okay, so we can see if we can give it a try. So let's run this interactively. Then we can create one game. One game is an RacquetBall game. The constructor requires two probabilities. So let's do 0.5 and 0.6 for 0.5 for player 1, 0.6 for player 2. Now what do we do is we can play. We can say one game dot play. Okay, so has no attribute server A. So let's fix that very quick. Server A, there's no. Okay, I think it's this line. 52. Yeah, 52. Okay, if self dot server that is player A. Okay, I think we fixed this. Change server. So recreate and play. So if everything is good, we should be able to say one game dot play. One more problem. I thought I saw this. Yes, line 55. Self dot server is self dot player. All right, so we're gonna give it one more try. Here we go. So we played one game. I think we played it successfully. And then what we can do is we can get scores to see which one is the winner. So we can say one game that get scores. And then here's another problem. Get scores. Get scores. Let's rename this. Okay, first I want to do is I want to rerun this with get score. It will work. 12 to 15. So it looks like player B has won. What we can do is we can replay the game, and then accept that when we replay the game, it's not going to play. We have to reconstruct it with the same probabilities. Then we can play. Then we can see who is the winner. 15 to 7. So So what else we can do is we can reconstruct. Okay. Let's give it 50% chance to both of them. Then we can play and then see who is the winner. Well, reconstruct, play, get score. Now it's 15 to 14, player A won. Okay, so this is how we implement the RacquetBall game. Alright, so finally let's implement the sim stats. So sim stats handles accumulation of statistics across multiple completed games. This version tracks the wins and shootouts for each player. Our constructor will create a new accumulator for a series of games. Our update method will determine the outcome of a game and update statistics. And then finally, our print report is a method to print a nicely formatted report, which I'll copy and paste this from my own solution. Okay, so let's define or design our constructor. Our constructor will have a self.wins a, which is set to 0, which keeps the wins for a, and another self dot wins b, which will keep the win count for player b, and a self dot shootout shoots for a, which is also set to 0. So another one is self dot shoot b, which is set to 0 as well. So when the game starts, all the stats are set to 0. So then when we play the game, we're going to update this. Okay. All right, so our update function will actually receive a game which will be constructed from the RacquetBall game. Okay, so if we have a game, then we can say what is A and B of a game that gets scores. I'm gonna rename this as scores. Then I'm gonna go up and rename this as scores as well. So first we'll construct a game, and then we're gonna pass this to update method, and then from that we're gonna get the scores for A and B. Then we'll define who wins. Okay, so the winners is if A is greater than B, and then we can say self dot wins A is self dot, or we can just say plus equal to 1. Okay, so remember, so if A wins, we can increase the wins A count. If, all right, so if that's when A is greater than B. Okay, and then we can say if B, let's construct this, and then we can say else self dot wins B is plus equal to 1. Okay, so it's one or the other one has to win. But now what else we can do is we can keep the count of shootouts. Shootouts is when A wins 7 to 0 and shoots B is when B wins 7 to 0. So how do we figure that out? We can say if A wins and then B is equal to 0, that's a shootout. And then if that's the case, we can say self dot shoots A plus equal to 1. Likewise, we can have this code here for B In that case, if A is 0, then self.should. This one is if A is 0, then B increase by 1. And that's it. So now I'm going to just copy and paste the entire code for print report, which I'm not gonna go over this again. Right, here you go. So we're fully implemented our RacquetBall simulation. And then what I want to do is now we can say that we can either manually run the main, or we can run it when we run the application. Let's do manual run. So I'm going to call main, and then main calls for print intro. This program simulates games of racquetball between two players, A and B, and then it calls get inputs. What is the probability for A? Let's call it 0.5. What is the probability for B? Let's call it 0.5. Let's play this 100 times. As expected, we have a problem here. Line 47. We go up. We forgot to change that. So it's now scores with S. All right. So I'm gonna rerun this. Okay. So call the main, and then 0.5, 0.5, and play this 100 times. So summary of 100 games wins. Player A wins 51 times. Player B wins 49 times, and then shootouts. Player A have 4 shootouts. Player B has 2 shootouts. So we can replay the game. And we can say, let's change the probability just a little bit. 0.5 versus 0.55. Just a little. So B is slightly better than A. See what happens. So let's repeat this 100 times. In this case, B wins 70 times, A wins 30 times. Right, so, and then finally, we can uncomment this, and we can just call Python to play the game without the interactive window. Okay, so 0.5 equal chances, 0.5. Let's play this 10,000 times. Here we go. So we have player A win this many times, 5,396, and then B 4,604, and then press enter to quit.